Hello everyone, how are you all? Welcome to CREATA CLASSES. This is the third lecture under the Angle Bisector series. In this lecture, we will cover the incircle and the inradius. So without taking any further time, let's start with the lecture. Let's take a random triangle ABC. This is the triangle ABC. Let's draw the angle bisector from the vertex A, B and C. These are the three angle bisectors. We have limited these angle bisectors only up to the incenter. I is the incenter, that is the intersection point of the three angle bisectors. We have not extended the angle bisector to the sides. In actual, these angle bisectors will touch the three sides of the triangle. But for this case, we have limited the angle bisector to the incenter only. Okay, that is the point I. So we got the three angle bisectors as AI, BI and CI. Let's draw the perpendicular from the incenter to the three sides of the triangle. ID, IE and IF are the three perpendiculars to the side BC, AC and AB respectively. Are you able to visualize many triangles in this figure? These are the 6 small triangles that are formed in this whole triangle ABC. If we take these two triangles, that is triangle FBI and the triangle DBI, are you able to observe these two triangles are the congruent triangles? Let's see how these triangles are congruent triangle. First of all, both of these triangles are a right angle triangle, that is angle F and angle D are right angle. Further, BI is the angle bisector of angle B, that is both of these angles will be equal to each other. If two angles of a triangles are equal, so we can say angle FIB and angle DIB will be equal to each other. Both of these angles will be equal to each other because rest two angles of the triangle are equal. Okay, any issue? Further, BI is equal to BI, that is the common side. BI is the angle bisector of angle B. So can we say angle FBI is equal to angle DBI? Both of these angles will be equal to each other. And just now we have seen angle FIB is equal to angle DIB. So by ASA, that is angle side angle rule, we can say both of these triangles are congruent to each other. Got it? So by CPCT, we can say that corresponding sides will be equal to each other. That is FI will be equal to DI. Basically FI is equal to DI. This is the result of angle bisector equidistance theorem. That is the part of the basic geometry. As per the angle bisector equidistance theorem, that is the additional to this chapter. I am just adding a small concept. As per angle bisector equidistance theorem, any point that is on the angle bisector is equidistant from the two sides of the angle. It means that if BI is the angle bisector of angle B, AB and AC are the two sides and BI is the angle bisector of angle B. If we take any point on this angle bisector, say point I, then this point will be equidistant from these two sides. And we have covered that the distance between point and the line segment is the shortest distance, and the shortest distance is the perpendicular distance. So in other words, we can say the perpendicular distance between the point and the line segment for both of these sides will be equal to each other. That is IF is equal to ID. This is angle bisector equidistance theorem. That is, if we take any points on this line segment, these points will be equidistant from both of these sides. That is, this distance will be equal to each other. And the proof of this theorem is that by proving both of these triangles are congruent to each other. That is, we have done. So you can use either way. Either you can say IF is equal to ID, that is by the angle bisector equidistance theorem, or you can use the congruency of the triangle to prove IF is equal to ID. I have just added this small concept in between our main topic. This is the part of the basic geometry. Moving further, if we take these two triangles, that is triangle AIF and triangle AIE, here also can we say both of these triangles are congruent to each other? We have used the same philosophy. So we got FI is equal to EI. Similarly, if we take these two triangles, that is triangle CEI and triangle CDI, we got EI is equal to DI. So by comparing all these three equations, we got Fi is equal to Di is equal to Ei. That is, these three line segments will be equal to each other, or the perpendicular from the incenter to the three sides are equal to each other. So if we are having any triangle with the incenter as I, so for that triangle we can say the perpendicular distance to the three sides from the incenter is equal to each other. We can also say the point I, that is incenter, is equidistant from the point F, D and E. The point I is at the same distance from the 3 point F, D and E. Are you able to catch that these wordings are matching with the wordings of the fundamentals of the circle? That is, the center of the circle is at equidistance from all the points on the circumference of the circle. So can we draw a circle with center as I, that is incenter, and the radius as IE, IF and ID? Okay, got it. This circle is known as incircle, and IE, ID and IF are known as the inradius. Incircles and inradius. Incircles touches the three sides of the triangle and it is inside the circle. This is very important concept. So we have covered incircle, inradius and incenter. Further, are you able to compare this with the fundamental of the tangent? Here AB, AC and BC are the three tangents to the circle. We know tangents are the lines which touches the circle at only and only one point. And we also know that tangent and the radius make the angle of 90 degree. Okay, here these three angles are 90 degree. So can we say AB, AC and BC are the tangents to this incircle? This is also the property of the incircle. So if we got a question that is to draw the incircle inside the triangle, how we will proceed? We will take the triangle. Firstly, we will draw the three angle bisectors of the three angles of the triangle. The point of intersection of three angle bisectors will be incenter. That is the center point of the incircle. Then we will draw the three perpendiculars from the incenters to the three sides of the triangle. That will be the radius of the incircle. Now with the help of compass, we will take the center as I and the radius as IE or ID or IF. We can draw the incircle. This is the procedure to draw the incircle. Got it? So we have done with incircles, inradius and incenter. So that's it for this video. Hope you have enjoyed the video. If you like or dislike, please mention in the below comment section. And thank you very much for being with CREATA Classes. Have a great day and best of luck. Bye for now.